All right, we should be recording. It's 7:35. So if you're watching this, other than one person who's in here, and you're obviously watching the video, so the instructions are as they usually are. You're gonna watch the video every time I say a screenshot, write it down. I mean, every time I say an attendance word or an attendance raise, write it down, take a screenshot when I say it, and then when you're done watching, send all the attendance words along with the screenshots. And as usual, the last attendance word is going to be asking a question about the material covered in the video. So that being said, first word for attendance, a phrase is Labor Day. For those of you who are watching the video, so Labor Day is your first word. You should take a screenshot. So I should see, what I'm looking at right now, which is the whiteboard and the screen and all that. But anyway, yes. So Labor Day is your first attendance word. You can go ahead and skip ahead. Let's see. Let's call it 7:35. There's 40 to 25. You can go ahead and skip ahead about 25 minutes, 24 minutes, and that's when the class will start. Excuse me. All right. Have a good week so far?
Yeah, so far. I am sore like a motherfucker.
From what?
In the gym.
That's good. Missed that. Still don't have any time to take care of myself.
I got you.
This. Had some gas yesterday. I mean, having breathing issues ever since.
What are you?
I'm saying I cut a bunch of grass yesterday. Now I've had breathing issues ever since.
That felt good.
Yeah. It's been so dry. It kicked up a lot of dust.
So is the lab in here or is it in a different room?
Yeah, it's in here.
Okay.
Do ask. Let's see. Excuse me. All right. Randall, you are now officially here with a little bit of extra credit again.
Hmm.
Morning, you two. see here. Bromfeld. Champion. That's why. You're up at the top. All right, so champion is here. Gunther's here, right? And the WBSU gear. I need to remember that. You got a few extra credit for that. Let's see. No. Slaughter? Okay. You wearing WBSU gear? By any chance? Okay, let's check. Stover, correct?
Yep.
In WBSU gear. Is it Austin? All right. In WBSU gear. And let's see. Lawrence? Yeah, all right. So far, everybody's accounted for. We are recording, so feel free to ask any questions you might want to ask. We don't necessarily need to start at 8 questions. And if it's a real good question, I'll repeat it once we officially get started at 8.
I got a question.
Yeah.
What's the restroom?
The restroom, there's one, like a single restroom on the other side of this wall. Then right past that is the entire men's restroom. Which reminds me, I never even said this during the syllabus discussion. You know, when we're in here, if you gotta go to the bathroom, go for it. You know, obviously it is a little bit disrupting if I'm in the middle of a lecture. So if there's 2 minutes left, then you feel like you barely have to use the restroom, maybe try to hold it. But you know, if there's a lot of time left and you're busting at the seams, do what you gotta do and just try to sneak out as stealthily as possible. You don't need to ask permission or anything. That's, you know, more disruptive. Slide on out. Is it Gracie? No. Sigmund? Nope. I was on a roll too. Zweibeck? No. Let's say Watson? No. Young? Man. Now I guess Gracie. I did. All right, well, go with hints again. What's your last name start with? What's your last name start with? Yeah. Oh, so I did, okay. I said your name. I got it right, but I also guessed a lot of other ones. So Zweibeck is here in WBSU gear. All right. Good morning.
Morning.
Ms. Smith with the WBSU shirt, correct?
Yeah,
Okay.
I wrote the.
You got a little extra credit. Gracie? Either one of you, Gracie? Oh, well. Sigmund? Either one of you, Sigmund? Watson? Watson's here. Young? Here. coming in from Brumfield. Yep, okay. Tompkins, NWSU girl, year, a little bit of extra credit for that. WVSU's Wednesdays. Like every day should be WVSU. Only Wednesday has the alliteration. Ugh. Morning. Oh man, negative extra credit for you. Why? It's just a joke. You're not going to lose any points, but WVSU Wednesday, you got the wrong university.
Oh, yeah, actually, but.
You know, choose another school. Just choose one that has a national championship. Anyway, sorry. Is it Gorby?
No.
Gross.
Yeah.
I get it. I give them a hard time. I might end up getting my PhD up there one day. But, even on the words. Who were they playing in their first game? I don't even remember. Robert Morris. That should be easy for them.
Our body is whatever they put it.
Oh, so you plan on going?
Okay.
Is that a home game or in Pittsburgh?
It'll be able to-
Yeah, probably. I went to one of their games once because I'm not from here, but my wife went to Marshall, so did her friend. So we went to the Marshall WVSU game, the WVU game. Everybody was just talking about how rude their fans are, and once I got there, everybody was actually really nice. And we were decked out in our Marshall gear, but still very friendly. All right, let's see here. We have Gracie. Yep. And Sigma, right? Okay. Neither one of you are wearing WVSU gear, right? So make sure people get the points. All right, it's 8. We'll get started. We're still missing a few people. I'll go through the announcements slowly, and hopefully some people will show up as I'm doing that. Before I do announcements, speaking of which, does anyone have your own announcements or anything that you want to mention to everybody? Nice and easy, okay. As usual, we're going to do the attendance words. If you're in person, you don't have to send them in, but if you do want to send them in for the extra credit, they have to be in by 9 a.m. First word for attendance, for those of you who are here, it's going to be the word Friday. And of course, if you're watching the video, you need to take a screenshot of the word for attendance as me pointing at it. So Friday is the first word for attendance. And again, remember, if you're here, you don't need those. Those are just extra credit. So what I'm really picky about, like you didn't send it in time, I'm not giving you your points. Don't feel bad. You're not losing points. You're just not gaining extra credit points. Oh yeah, and then as usual, again, at the end, the last word for attendance is going to be me saying, ask me one question about all the information covered in this lecture. Try not to go too fast. I'm hoping some more people show up. Lab is today. Our first lab is today at 9. Be here on time. It's really not hard to be here on time because you're already here, right? So, basically, if I were you, I would just take those 10 minutes between lecture and lab just to go do whatever you need to do, stretch, make a phone call, whatever it may be. It's in the same room, right? So we're not going anywhere. It's going to be in here. Usually I lock the doors at 9 because, again, this is a team effort. So if people aren't here, if they come in late for a lab and they're affecting the whole team, that's not fair for the rest of you who are here on time. Today is an exception because it's the first week, so I will start a little slow. As a matter of fact, since it's the first week, Don't tell anybody. If you guys have friends who aren't here, don't text them and say, you said you can come in late. But yeah, for this 1 week, I will let people come in a little late. But yeah, that's one of the few things I am picky about, is being on time for lab. Obviously lecture, whatever, you're okay. If you haven't done the pre-lab, you can't come. There's at least 2 of you, you know who you are. I've sent you an email, I've sent you a number of emails. Like when you missed the due date the first time, I said, hey, you gotta get this in by this date, otherwise you can't come in. Then you missed that due date, so I said, okay, you need to have this done by this date, and now you need to do these extra things to make up for the fact that it's late, otherwise you can't come in. And then you still haven't responded. So for those 2 of you, you know who you are, you just can't come in. But like I said earlier in that email that hopefully you've read by now, since this is the first week, normally you would not be able to come in, you get a 0 for the week. But in this case, since it's the first week, you could just do the lab without coming in, because this is gonna be the data. I'm gonna take a picture of it and I'll share it with you. So that's the only data you need really to do the lab. And then of course you'll have to do that extra lab that I've already sent you. And for the rest of you, I'll send you that extra lab later. It's an online version of the first lab, and you can do it for extra credit. So for example, if some of you who are here right now do the lab and you don't get full credit, you just do that extra lab, and those points will be applied to your lab. You can have full credit, so on and so forth. But any questions about that? Make sure today, or make sure for every lab you wear pants closed toe shoes. I know that's the first time I told you. So if you don't have it today, it's no big deal. Also, today's lab is very safe. We're not dealing with any kind of chemicals or anything, so it doesn't really matter. But yeah, moving forward, make sure you wear pants and closed-toed shoes. How many of you live off campus? Okay, quite a few of you. I did too when I was a student. So what I used to do was keep a pair of pants, or like sweatpants and shoes in my trunk. Because even though I was a biology major and had labs all the time, I would sometimes forget, and I just had to run out to my car and change really quickly. Your lab itself, I'm going to mention this again during lab, it's due before you leave. So you're going to upload your lab before you leave lab today, sometime before 10:50. That's when it's due. Now, if you look, it says past due on Friday. What that means is, hopefully, my goal is to grade it as quickly as I can. That way, if you have any mistakes, you have until Friday to fix it. That make sense? Okay, so make sure you upload it before you leave today. That's part of my attendance thing. Like, I'll take attendance when we start, and then to see who got here on time, and then you turning it in before you leave tells me who stayed the whole time and followed the directions. That's it for lab questions. Any questions about lab today? Still trying to go slow, hoping more people show up. All right, the pre-lab for the next lab is due on Friday. Yeah, just like usual. So for both of them, I'll remind you, you don't have to do any of this alone. Obviously, for today's lab, you're not going to do it alone. We're going to be working together. So I'll focus on the pre-lab. The next pre-lab is the example. If you want to, like, meet me online during office hours or else any other time, we could just work on it together. Like, I'll say, okay, read this section, let me know when you're done. And then you read it, and you say, okay, I'm done. I'll say, okay, do you have any questions, or you're good to go? And then you say you're good to go. I'll say, okay, now read this section. Let me know when you're done, right? And I can just walk you through it. I prefer it. I don't like, I'm not looking down on anything, or this student can't do this for themselves. I look at it as like you're taking me up on my offer, which is me helping you do it. I prefer that. That way I can actually teach you instead of just throwing you at it to figure it out for yourself. So yeah, any questions about the pre-lab? All right. And again, this is now no longer the first week. So if you miss the due date for the pre-lab on Friday, then you cannot come to lab on Friday, next week. Won't be any extensions like there were this time, because we should know how it works. There's no school on Monday, as a reminder. So next week on Monday is Labor Day. Nobody will be here. Well, some people might be here, but class will not be happening. I will not be here. I will not be holding office hours online or in person. So yeah. And then next Friday, so not this coming Friday, but the week after that, right? The Friday after Labor Day, my office hours are going to be online only because I'll be traveling. So those are the announcements and reminders. Any questions? So is that a no or the yes? That was a question. No? Okay, thanks. All right, so let's get back into it. We were talking about the scientific process, and we were talking about the fact that after you're done with your experiments or whatever, that you would often publish your work. Now, obviously, you would think this is not very important for you because I've asked you before, and none of you are biology majors. So most likely, most of you are not going to grow up and turn in or be trying to publish biology papers. But it's still important you know a little bit about this. This is why we have the discussions, which of course are extra credit for you now. But the extra credits require you to look at different sources. Hopefully, some of them are peer reviewed, and you definitely need to know what peer reviewed is. Peer reviewed is basically just a process for quality control. So when someone, this is kind of a bad picture, because this picture does not go with peer review. This is just a couple of students who have done some work. Like if you look in the hallways, there's a bunch of posters from students here who've done some work. That's the same situation there. But peer review, so when someone does a study and they want to publish it, it has to go through a process. It's not like they can just send it in and, you know, an editor looks to make sure the English is fine and the grammar's fine and they post it or publish it. It's not like that, right? It's a process that provides quality control. The research is evaluated by qualified, impartial, and often anonymous experts that are not involved in the study. Peer review is not perfect, but it's the best thing we have. So when you look for information, you know, like, is this vaccine dangerous or whatever, you should look for peer review because there's a lot of misinformation on the internet. And there's even a little bit of misinformation for peer reviewed stuff. But again, it's better than nothing. I can make a YouTube video and just claim anything, especially since I know biology. I can make some pretty good and convincing lies. But if you get it peer reviewed, it's more likely to be accurate and true. And later, I'll talk more about peer review because this is important for your everyday life. Because again, as a college-educated citizen, you should be questioning things. You shouldn't just be accepting information people give you. And not all peer review is equal. So some journals are not that good. And some of them literally are just, people will publish hypotheses. Like they won't even do experiments. They'll just like write about like, I think this is this. And they'll talk about why they think this is this and how they might test it if they were to test it. And there's literally journals that just publish that. And people who don't know what that means will read that journal like, hey, this person thinks this is this. I told you this was this, but they never proved it or they never supported it with any experiments. They're just saying, this is my hypothesis. So anyway, we'll again talk about that throughout the semester. So any questions about peer review? All right, let's talk about evaluating scientific claims. You and I get tested on this, but well, you might get a couple of these words in the exam. So take a note. What I'm about to tell you is not in the textbook, but you might need to know. So does anybody know what pseudoscience is? Anybody tell me what pseudoscience is? Or give me an example of pseudoscience. Like maybe you've heard somebody say some pseudoscience or share some. All right, how about the prefix pseudo? What does that mean generally? Like not generally speaking, what is the prefix pseudo? You guys are being shy. Surely someone knows. Maybe you're just afraid to be wrong. Don't be afraid to be wrong. What does pseudo mean?
It's like fake.
Yeah, there you go. Perfect. Basically fake, right? So therefore, pseudoscience is basically fake science. Or as your old textbook defined it, it's the field of study falsely presented as having scientific basis. So yeah, fake science. There's a lot of it out there. The internet has made it bad. AI has made it worse. Polarization of our country, politically has made it worse. Like people argue about science now. Like, oh, you should don't worry, eat all the bacon you want. Fat's good for your arteries. No, it's not. But anyway, that's what pseudoscience is. There's several indicators. This is so important because again, I call this the age of misinformation, the misinformation age. There's so much misinformation out there. So here's the first indicator. One of them is anecdotal evidence. Who knows what that is? Anecdotal evidence. It even sounds scientific.
Yeah.
But what is it? Does anybody know? Anecdotal evidence. I'll give you an example, then maybe you can define it. What if, like, all right, so your aunt says, you know, I was feeling fine. I've always felt good. I never had problems with I don't know, with my breathing. And then I took this medication for my arthritis, and now I can't breathe. And I can't breathe properly. And she's like, that's a dangerous medication. That is anecdotal evidence. And let me give you an example of not anecdotal evidence. If you were to look up the same drug, this is hypothetical, right? So I don't know if this is true or not. Maybe you look it up, like, oh man, I don't want anybody my family taking this dangerous drug. So you look it up, and you look up the statistics, and like, I don't know, 0.01% of the people who take it do indeed have kidney problems. But generally speaking, it's really safe. So that would be an example of not anecdotal evidence. So now, anybody, do you think you could describe anecdotal evidence? All right. Here it is. Anecdotal evidence is evidence that's based on single or a few examples and it doesn't support generalized conclusions. It's very powerful and it's very dangerous. Especially with vaccines, right? So you can read all this information about, I don't know, pick any vaccine. It was like, this is overwhelmingly safe and it overwhelmingly protects the person who takes it and it overwhelmingly protects the community. But there's this small chance that this might get this side effect, right? You could read that all day and be like, okay, that sounds okay. But then if you know one person who's like actually took it and like, man, next thing you know, I've got heart problems. So that's why it's so dangerous, because that's more compelling, right? It doesn't matter how many, you look at the study that has thousands of people that were studied, but those are just numbers on a paper. If you know somebody that something bad happened to, it's like, wow, that's scary. So even though the evidence is less useful scientifically and to be realistic, it is useful as far as changing people's mind because it's just scarier. And one of the problems with anecdotal evidence, especially in this example I gave, is there's no scientific basis to it, right? So it's a lot of, yeah, maybe I took this and then this happened, but that doesn't mean this happening was because you took this, right? Just because, what do we say? Correlation does not equal causation. And we'll talk about that throughout the semester too. Just because two things occurred doesn't mean this thing caused that thing. It's a good starting point though, right? If this thing happened and then that thing happened, you might look into it and say, is there a reason that this happened? Did this thing cause that thing? Anyway, that's sort of anecdotal evidence for extra credit throughout the semester. If you find any examples of someone who shared anecdotal evidence, feel free to write a paper about it and send it to me for extra credit. All right. The other big thing when it comes to pseudoscience is your sources of information. So when you're seeing some information out there and you're wondering if it's pseudoscience, you have to say, okay, well, where did it come from? Did it come from a peer-reviewed article? That's one of the things we just talked about. It was peer-reviewed. I'll give you an example. So I saw something with that Impossible Burger came out, so Impossible Whopper, something like that. It's fake meat, and they use soy and things like that. And I saw some paper just talking about how unhealthy that was for you. And I don't even remember the details, but anyway, and then I was like, well, this sounds like BS, because again, unfortunately, people politicize science. So I looked at it and I started digging. I'm like, is this pseudoscience or not? And it turns out it was peer-reviewed. But that brings me to my next point. Was it from a company trying to sell you something? Of course, you don't necessarily need to take notes on this if you don't want, because I'm definitely not going to test you on this, but this is really good information for your everyday life. So going back to my example, and this is a real life example, it was peer-reviewed, but I looked at it and I don't think there was an issue with necessarily who reviewed it. But then, and I should put a bullet point up here for this. Then I looked at the author, and the author who wrote the study was the president of the Texas Cattle Association or something like that, right? Somebody who stood to lose a lot of money if people were buying non-beef hamburgers. So then I knew at that point, yep, I can see how this is pseudoscience. And yes, it was peer-reviewed, and we're not wasting a lot of your time talking about it. Basically, he mentioned a lot of bad stuff, like the list of ingredients, and sometimes this ingredient can cause this bad thing, and this ingredient can cause that bad thing. But when I really put all of it together, it was pseudoscience. And that's something else we'll talk about a little bit later, especially when we talk about chemistry, which hopefully we'll start that chapter today. There's a lot of chemophobia, where people are like, this ingredient does this, and this ingredient is also in your food, and they're trying to scare you. Anyway, yeah, so That's my thing on pseudoscience. This is a big one too. Or does it come from a company trying to sell you something? You see that a lot, especially these wellness influencers and all this garbage. Like, oh, you're gonna eat that. That's so horrible for you. The government's trying to kill you, and the society's trying to kill you by getting you to eat this. And then they're like, but $59.99, you can buy this from me, and it's perfectly healthy, and it'll help cleanse your body from all these bad things you've eaten. So yeah, pseudoscience. You guys are surrounded by it. It's an important topic. All right, next slide. This is not in your textbook. So again, I'm not going to test you on this. It's probably impossible for you to read. But I wouldn't hurt you to download this and just look at it. Maybe keep it handy. It's like gives you the features of science versus the features of pseudoscience. I'll read the first one and we'll move on. Science adheres to an established and well-recognized scientific method. Pseudoscience does not. We'll just leave it at that. You can read it. There's a bunch of other stuff I'm not going to test you on. This one also is not in your textbook, and you might want to keep this handy too for your everyday life. It's like a little checklist. The source reliability checklist. Is it current? Oh, that's a big one too. People share like old information, like sure, that was the case then, but now there's new studies that say that's no longer the case, right? This is a big one, and it's going to be harder for you guys. Is the source primary? Usually, in my opinion, what you're going to see is not primary, unless you're looking at peer-reviewed journals. Usually, what you're seeing is a journalist who's writing about a primary a study, right? So usually the scientists themselves, when you guys read it, because you're not scientists, when you see something on the news or social media, usually as a journalist who's taken what a scientist did and trying to write about it so the layman can understand. And I'll admit too, like if you read stuff that's primary sources, like peer-reviewed journals, a lot of times they are really hard to read, even for me. This is what I do. Anyway, I'm not going to go through that whole checklist. You can look at it if you want. The next word for attendance is going to be circled. I know. Can everybody see that? Yeah. So that is the next word for attendance. So of course, if you're watching the video and you screenshot it, see that it's circled right there. Anyway, again, for extra credit throughout the semester, just you can be a little pseudoscience detectives. Whenever you see an instance of pseudoscience, write about why it's not pseudoscience. Pretend like you're responding to them. Don't do that though, because people get pissed off unless you want to. But if you think something's pseudoscience, write to me as if I were the person posting it and tell me why you think it's pseudoscience and all that stuff. People love to argue on the internet, right? So now I'm kind of inviting you to argue with me on the internet, and I'll pretend like I'm that person sharing the pseudoscience. Anyway, any questions about that? Good. Now we are done with the basically introduction stuff. Now we're really going to move into the real stuff for biology. That was your introduction. Now we're getting into the meat and potatoes. Chapter 2, Chemistry of Life. Oops. This is great. Show it. How many of you took biology because you didn't want to take chemistry? No. Well, the good news is, the bad news is, obviously we have chemistry. There's a whole chapter devoted to it, and there's going to be quite a bit of it on the exam. And even though this course isn't cumulative, like I mentioned earlier, to truly understand all the stuff that you're going to learn after this, when you learn about how cells work, to truly understand that, you need to truly understand this chemistry that I'm about to teach you. Now, granted, you can get a basic understanding, so if you don't do good with chemistry, do well with chemistry, you can basically understand the stuff I'm going to teach you later, but to really understand it, you need to really understand this basic chemistry that I'm going to teach you. So, yes, we will have chemistry. The good news is, though, actually, how many of you have had chemistry? Okay, so for those of you who have had it, in my opinion, it's a lot easier than real chemistry. It's a lot less math. This is just the basics. So, here we go. Oh yeah, another thing. The old textbook, let's see, it broke this down. So the old textbook, there was a chemistry chapter, which is where we're going to start here. Then there was something called biological molecules, which is still technically chemistry, but then we were very much focused on specific types of chemistry that are only specific to biology. But this textbook merges them all into one. So I've done the same thing. I guess the point is, again, just like the previous chapter, there is going to be some stuff that's a little bit out of order than it was in your textbook. There's going to be some examples and pictures on here that are not in your textbook, stuff like that. So just something to keep in mind. Speaking of which, this one right here, like I mentioned last chapter, with the old textbook, every chapter started with why blank matters, right? Why does this chapter matter to your everyday life? So since we're not behind, we'll continue to do the same thing. Why chemistry matters. So this is kind of like a little guessing game. This is really hard to see, but can anybody tell what this is? It is coral, yes. All this is coral underwater. Does anybody know what's up with this particular piece of coral?
It looks like it's bleached.
It is bleached, good. And that might not matter to you much, to like, hey, that's a little bit sad, right? But unless you're scuba diving or snorkeling, or unless you live in Key Largo, like where I went to high school, and your economy is based on people scuba diving and stuff, you might not care. But it does matter, and we'll talk why that matters, like why coral matters to you much later in the semester. But when it comes to chemistry, why this matters is there's acid, right? We are making the oceans more acidic because there's a chemical reaction where carbon dioxide mixes with water and it creates an acid. I'll demonstrate that next week in lab. I'll literally have get a thing of water, put a little pH indicator in there, and based on the color, you'll be able to see that water is neutral. And then I'll start blowing into it, exhaling all my carbon dioxide into it and causing bubbles. And you see the color will change, indicating that water is turning acidic because I'm putting carbon dioxide in there. So yeah. And again, right now you might not care. Like, oh, who cares if coral dies? Sad a little bit, but how does that affect me? So later in the semester, that's when we'll talk about that, how dead coral can affect you. How about this picture right here? What's going on here? Good, salt on fries. And this goes back to the chemophobia thing I've taught you, mentioned earlier, where people try to scare you because if you don't know enough about chemistry, you're going to be easily tricked and scared. Does anybody know what salt is, this particular salt that's going on fries? The kind of salt you would buy at the store. What is that made of? Because again, a lot of times when it comes to people trying to trick you or scare you with chemistry, they'll say, oh, you're eating this thing. Here's the ingredients of this thing you're eating. And then they're like, did you know that this is this? And it tries to scare you. So does anybody know what salt is made of? Especially those of you who have had chemistry, you should know this one. What's a guess? It's 2 parts of salt. I think you're about to say it. Sodium is the first part, yeah. Does anybody know the second part? Nope, okay. Sodium chloride, not that you need to know that, but it's such a great example. Sodium chloride, it tastes great. You need it. Like sodium chloride, you need salt in your diet. Of course, if you have too much, it can be very bad for you, but you do need it in your diet. We'll talk more about that later in this chapter. But sodium chloride is a great example because does anybody know what sodium is? It's a metal. It's an explosive metal. It's a very dangerous explosive metal. If you get it wet, it explodes violently. Chloride, or chlorine, it's a gas. It's a poisonous gas. It's been used to kill people. It was used in the military in World War I a lot, right? So here you have an explosive metal, and you have a poisonous gas. You put the two together, and you have something that's essential for your body. So that is such a great example of how people can try to scare you with chemistry. Like, oh my God, you're putting that in your body? That's used to, clean engines or something. Or that's only 1 molecule away from being this. Like, well, okay, it's 1 molecule away from being this, so it's not that. But anyway, we'll talk more about that later. Anyway, speaking of which, anytime we talk about these things, you can look this up or look this up and write a paper for extra credit. Anything that you need in your body, you can look it up and say, all right, what happens if I have too much of it? And what happens if I don't have enough of it? Because salt's a great example, right? Too much of it is bad for you, you get high blood pressure. But you also need it for other things that we'll talk about later in the semester. Anyway, this one's a lot less important, but can anybody tell what this is? Yeah, it's copper. So, yep. Copper is just an element. You're going to learn more about what elements are. As far as this class is concerned, copper is not important. Anyway, any questions so far? All right, here we go. This chapter is broken down into 3 parts. Sorry if this is hard to read, but the 3 parts are going to be the building blocks of molecules. This is the real basic chemistry. Then we're going to talk about water. Obviously, like we mentioned in the last chapter when we were talking about that Mars rover and saying, what was it looking for? It was looking, amongst other things, it was looking for water. Why is that important? Because where there's water, there could be life. So water is obviously very important for life. We'll talk about that portion. And then finally, we'll talk about biological molecules, which again, in the previous textbook, that used to be a separate chapter. As a matter of fact, because of that, where's my pin here? This part right here is what next week's lab will be. And then this part right here is what the week after that's lab will be. So this chapter covers 2 labs, or 2 labs cover this chapter. Anyway, 2.1, the building blocks of molecules. Again, I apologize if this is hard to read, but you're not, damn near impossible. I can't even read it. You're not going to get tested on this, but the learning objectives for this portion are, by the end, you should be able to describe matter and elements, and you should be able to describe the interrelationship between protons, neutrons, and electrons, and the way in which electrons can be donated or shared between atoms. So atoms, I've said that before, I've said it again. Does anybody know what an atom is? ATOM, not like Adam Sandler. Anybody want to guess what an atom is before I put the definition on the molecule? I like, because you're in the right chapter, you're in the right area, because if you put a bunch of atoms together, or at least 2 atoms together, you can make a molecule. So that's a good hint. I think this is one of those words where people know what it is, they just don't know necessarily how to describe it. As I think you guys demonstrated earlier, some of you guys are a little too shy, because I think most of you use sodium chloride with salt. You just didn't want to be wrong. Don't be afraid to be wrong. Wrong answers are the best, because then I can know what you're thinking. And if you're thinking it, your classmates are thinking it. So instead of me just teaching you something from scratch, I can start from where you were wrong and work on how that's right. But anyway, each element consists of one kind of atom. So if you look back there in the periodic table of elements, there's 92 naturally occurring elements. There's a bunch more just elements in general. So each one of those elements has a specific kind of atom. But the definition of the atom, and I might or might not ask you, you definitely need to know how they work, but I might not ask you the definition of an atom, but here it is anyway. An atom is the smallest component of an element that retains all of the chemical properties of that element. Basically, it's like you can't break it down anymore at the smallest piece. Once you break, if you were to break, again, using gold as an example. If you have a bar of gold, that's a lot of atoms of gold. If you kept physically breaking it up, eventually, technically, you could get to just one atom of gold. And once you broke that down, though, it would no longer be gold. And here's a better example, since it's on the screen. Not that you need to know this, but this is helium. The reason I know it's helium is because it has 2 protons. I'll explain that later. So there we go. Helium, there's a bunch, like if you have a tank of helium gas, there's a bunch of these atoms, right? But if you break it down and break it down and break it down and isolate it, eventually you could get to this one atom, and this is as small as it gets. Because if we were to break this down, specifically if I were to take away one of those protons, it would no longer be helium. So again, that is the most basic component of an element, is an atom. So any questions about what an atom is? All right. So what are atoms made of? You can see them here, even though I don't necessarily expect you to know this yet, and I'm sure some of you do, especially if you had chemistry. First of all, what are these 2 things? I already did just say that. What are those 2 things that are positive?
Protons.
Good, protons. Positive protons with a P, that helps. What about these negative things out here?
Neutrons.
Ooh, I like it, but you're on the right track, because neutrons is one of the answers that I'm about to ask you. But it's negative, right? So protons are positive. Those things are negative, so we know they're not neutral. But again, neutron is a great guess, because neutron will be the next one. So does anybody know what these things are? They're negative. Good, electrons. Since you already answered the last one, I won't ask it again. Those green things are neutrons, and they are neutral. Anyway, here's everything I just said in writing. You need to know this for the exam. So the parts, again, an atom is the smallest thing that makes up an element, right? But the atoms themselves can be broken down into different parts. Of course, we're no longer talking about an element anymore when we're talking about the different parts. We're talking about just this one atom and the parts that make it up. But the subatomic particles include protons, electrons, and neutrons. You need to know that. Not in that order either, that's just the order I put them in. But you definitely need to know that. You need to know that protons have a positive 1 charge and a mass of 1. And we'll talk more about the mass later. For now, that's just an introduction. You need to know that electrons are negatively charged and essentially have no mass as far as we're concerned in this class. And then finally, you need to know that neutrons are neutral and also have a mass 1. Definitely need to know that for the exam. Or an extra credit paper. Or if you don't want to write a whole paper about it and just want 1 point of extra credit. In a separate email, so not the one, so don't look it up now. And also, you don't send it in with your attendance words. You can just send it anytime after lab. Oh yeah, don't even send this to me until after lab. Don't even look into it until after lab. But again, I'm telling you, as far as we're concerned, electrons have no mass. But if you want to, just out of curiosity, you can look up and tell me what their mass actually is. So again, as far as we're concerned, no mass. But if you really wanted to get into it, that's not necessarily true. Anyway, here's something else you need to know. If the number of protons equals the number of electrons, so if you have the same number of positive things as you do negative things, then that means the atom is neutral. It has no charge, which should make sense, right? When positives balance out the negatives, it's neutral. We'll talk more about this later, but I'll go ahead and introduce you to the concept right now. Obviously, that means if something has more electrons than it does protons, it's going to be negative, right? Because electrons are negative. If something has more protons than electrons, it's going to be positive. Obviously, right? Because protons are positive. But again, that's a concept we'll dive into officially later. For now, that's just an introduction. Does anybody have any questions about this slide? Pay attention to this slide, because after I go to the next slide, your attendance word is going to be a question about this slide. It's going to be a multiple choice question. I'm going to ask the question, and the correct answer is going to be one of these 3 words: proton, electron, and neutron. So here we go. If there's no questions about this slide, we'll move forward. And I'll ask you, between protons, electrons, and neutrons, which one has a negative charge? Nice and easy. Oh. So those are the parts of an atom. Now let's talk about the structure of an atom. The first thing we're talking about is the nucleus, which is the inside of the atom, right? It's the very middle of the atom, the central core. And what you need to know about the nucleus is this. Well, I guess technically both of these bullet points is more important. The nucleus itself is made up of protons and neutrons. The electrons are just found on the outside. And we'll talk more about the electrons being on the outside later. For now, just know that they're not in the nucleus, they're on the outside. For now, just know that the nucleus consists of protons and neutrons. I'm about to give you a little bit of extra information too that you don't necessarily need to know for the exam or for the rest of the semester, but it's sort of interesting, I think. Does anybody remember what charge protons have? Positive, right? Positive protons with the P's, that helps, right? They are positive. This is a uranium nucleus, just not that you need to know that, just as an example, which means if you were to look up there, you would see that this thing has 92 protons. And like he just said, those are positively charged. What happens when you put 2 things together that have the same charge? Or basically the same way of asking, what happens when you put 2 magnets together and you put the same part together, like north to north or south to south? What happens when you try to do that? What is it? They won't go together, right? That's an understatement, but yes, they won't go together. They repel each other, right? Positive things repel each other. So imagine this, if you will. Uranium, in this example, has 92 protons, all repelling each other, but there they are squished together in that tiny little nucleus. So here's a concept and a theme that I'm gonna talk about a lot, especially through this chapter. There's a lot of energy that must be holding those protons together, right? Because they don't want to be together. They're positive. 92 things trying to repel each other, squished together. Like imagine trying to hold 92 things together in your hands that are trying to push apart, right? That would be hard. That would take a lot of energy. Not that you need to know this, but that is what nuclear energy is. Nuclear energy is the thing that keeps those things together. And it's a very strong force, obviously, to be able to keep those things together. So if you were to break that, that means you also are going to release the amount of energy that's holding it together. And that's what nuclear energy is. That's what nuclear bombs are. When you break that thing, all that energy that's keeping it together is released. And again, you get a nuclear bomb, or if you control the release of that energy, you can turn it into electricity. So that part is not relevant to this course. What is relevant to this course is that concept. I'm going to talk about it a lot. As far as we're concerned in this course, it takes energy to build things and keep things together. And however much energy it takes to build something and keep it together, that's how much energy will be released when you break it. So some things have a lot of energy because it takes a lot more energy to squish those things together, right? So therefore it's harder to break them, but when they do break, it releases more energy. Some things are easier to put together. So when you break those things, less energy is released. That's going to be a very important concept for, let's see, this exam and even the next one. So that concept is going to go for a while. Anyway, any questions about this slide? All right, here's another example. This is a picture from the old textbook. Again, we're looking at helium. Like I said, we got protons and neutrons in the nucleus. We have the electrons on the outside. I like this picture better than a lot of the other ones. It's a little bit hard to see, but that's like a cloud, and I'll explain why later. But yes, the electrons on the outside, protons and neutrons on the inside. Protons are positive, neutrons are neutral, electrons are negative. And that should be easy to remember, right? Proton starts with P, positive starts with P. Neutrons are neutral. It's in the name. Electrons, by a process of elimination. If you just remember protons are positive, neutrons are neutral, electrons are the only ones left, so they are negative. Another way to remember that is imagine getting electrocuted, right? That would be a negative experience, right? So electrons are negative. Anyway, any questions about that slide? All right, nice and simple. We'll make it a little bit more complicated with this one right here. Does anybody know what the atomic number is? So looking at this, not that I expect you to yet, I'm just curious if anybody still remembers all this from chemistry. If I ask you, looking at this, what is the proton? I gave it away. There we go. Anyway, you will need to know this. The atomic number is the number of protons. So if I were to give you a picture of any atom that you've never seen before, you should be able to tell me its atomic number, because all you have to do is look and count the protons. Or if I were to write it down, or like, that's not write it down, excuse me, if the question described it, say giving you a picture, it describes it and says, hey, this thing has 5 protons. What is its atomic number? Its atomic number will be 5. Atomic number equals the number of protons. You have to know that. Also, and I don't think your book words it this way, but I like to word it this way, the number of protons defines the element. So you can't change the number of protons without changing the element. So again, that last one I just showed you was helium, that has 2 protons. If you were to take away a proton, it would no longer be helium, because when something has 1 proton, it's hydrogen. Those are just examples, you don't need to memorize that. Also, if you were to take helium and add a proton to it, it would then have 3 protons instead of 2, which means it would be lithium instead of helium. And again, those are just examples. I'm not going to ask you about the relationship between helium and hydrogen and lithium. The point is, what you do need to know is when you change the number of protons, you change the element. So there will be test questions, and we're going to get to the rest of it later, where it's like, all right, what happens when you change the number of protons? What happens when you change the number of electrons? And then finally, what happens when you change the number of neutrons? So you're going to need to know that, and I'm telling you now for the first one, when you change the number of protons, you change the element. An element is defined by its number of protons. And again, I'm going to put it next to this just to visually remind you. Helium is just an example. I'm not going to ask you any questions. Like, I'm not going to ask you to memorize them. You won't get a test question that says, how many protons does helium have, right? But I might say something like, helium has, like, write this out in the question. Helium has 2 protons, 2 neutrons, and 2 electrons. what is its atomic number? Of course, that'd be easy because it would have to be, well, I guess that could be tricky. But anyway, the answer is 2, right? Because it's the number of protons. But like I said, that could be tricky, and here's why. Because you have to remember what an atomic number is versus the other things I'm about to teach you, such as a mass number. You need to know what a mass number is. And that's basically the protons plus the neutrons. So helium, again, just using the same example, not that you need to memorize this. The helium's mass number is 4 because it has 2 neutrons and 2 protons. 2 plus 2 is 4. So again, a test question might say, helium has 2 protons, 2 neutrons, and 2 electrons. What is its atomic number? 2. What is its mass number? 4, right? Because 2 plus 2 equals 4. You definitely need to know the atomic number and mass number. By themselves, those concepts aren't complicated, right? The trick is going to be remembering what I'm asking for, right? All right, atomic number versus mass number, which is which. So hopefully you'll be able to remember that for the exam. There's a third one too, which is going to make things even trickier. But for now, does anybody have any questions about this slide? All right, so this one's where it gets really tricky. There's the mass number, which is really easy to figure out. It's the protons plus the neutrons. Oh, speaking of which, before I move forward, let me give you another example of a test question. I might say the mass number of some hypothetical element is, I don't know, 7. That's the mass number. Let's put the mass number right there. And mass number is 7. Imagine this is written out as a question. And it has, I don't know, 4 protons. How many neutrons does it have? Those are the kind of basic math questions you're going to get, right? So I would say, again, this hypothetical thing has a mass number of 7. It has 4 protons. How many neutrons does it have? And of course, I already wrote it on there for you. It would have to be 3, right? Because basically that's asking you what plus 4 equals 7. So be ready for that. And I'll go ahead and tell you there will be a trick question. I'm saying trick with quotation marks. I'm telling you now it's going to be there, so it's not truly a trick question. But one of these questions is going to be set up like that, and you're going to think it's asking you to do some math, but it's not. And again, it'll be something like its mass number is 7. I don't know. Its proton number is 4. What is its atomic mass, right? And then you might be thinking, oh, he's trying to ask me a math question. But if you paid attention to the wording, it should be easier when you can see it. I said the proton number is 4. Then I asked you what the atomic number is, right? So be careful with the questions. There will be one that it's set up where it sounds like I'm about to ask you a math question. But it's really just asking you to pay attention to the fact that I asked you for the atomic number, which is the number of protons. All right, so let's talk about this. Probably the last thing we talk about for today. The atomic mass. And this is where it's not really explained in the textbooks. There'll be very few questions about it in the exam, if any. But I think it's important. And it also makes things tricky, right? So you've got the mass number, which is the number of protons plus the number of neutrons. And you've got this new thing called the atomic mass. So it's similar to the mass number, but it may differ. And it represents an average of all naturally occurring forms. And I'll explain what I mean here in a second. So go back to one of the first things I taught you about atoms. I told you a proton has a mass number of 1. And a neutron has a mass number of 1. And the electrons, as far as we're concerned, have a mass number of 0. Now, if you were to look at the periodic table and look at the atomic mass, as opposed to the mass number, you would see, like helium, for example, its atomic mass is 1.00784. But think about that. We're breaking this down as much as it'll break down, right? You've got protons and neutrons. Their number is 1. It's a whole number. You can't break, as far as we're concerned, you can't break a proton down. You can't break a neutron down. So what I'm saying here is that hydrogen, again, use that as an example, its atomic mass, if you look it up, is 1.00784. But there's no single hydrogen atom in this universe that weighs 1.00784. Because we're dealing with whole numbers, right? There's protons and neutrons, whole numbers. So we don't have that. But if you were to look at all the hydrogens in the universe, you would see that some of them look like this, and they have one proton and one electron. Some of them actually have a proton and a neutron. And even fewer of them actually have one proton and two neutrons. So in the universe, these are all the different types of hydrogens. So what we're saying is if you were to add them all up and average their weight, then their weight on average would be 1.00784. So what you can tell by looking at that number, even though you're not going to need to do this for any kind of exam, I can tell by looking at this number, well, let's see if anybody else can guess it. Based on this number, like I'm saying, this is the average mass of all the hydrogens in the universe, is that. So what do you think? Do most hydrogens in the universe, do they look like A, B, or C? This thing's mass is 1. This thing's mass is 2. This thing's mass is 3. All right, what if you were going to a daycare? You looked at a daycare that's got 1,000 kids in it, with daycare. And I told you the average age of those kids is 1.00784. And we're only talking about, we have a bunch of 1-year-olds, 2-year-olds, and 3-year-olds. What do you think most of those kids, what are the age of most of those kids? We're not talking about months. We're just talking about how old are they in years. We've got 1-year-olds. There you go, 1, right? You tell me looking at this number, it's so close to 1. Obviously, there's a lot of 1-year-olds, not that many 2- and 3-year-olds. Same thing with this example of hydrogen. Not that I'm going to ask you this in a test, but based on this number, you can tell most hydrogens in the universe must be this one with a mass of 1. Not a mass of 2, not a mass of 3, with a mass of 1. Anyway, any questions about atomic mass? All right, since we have lab, let's just say the last word for attendance is going to be hydrogen. Hydrogen's the last word for attendance, other than the fact that you need to ask me one question about the information presented. So that's it. We'll end 2 minutes early because we need to be back here by 9 a.m. sharp to do the lab. That's it. This lab's going to be a long one. I apologize in advance. It's the first lab. So, and you guys have already done the pre-lab, so that was probably overwhelming too. So just to remind you, it all gets better after this. The labs, for the most part, won't be as long or complicated, like the lab worksheets themselves. The labs themselves will meet probably